Hey guys, so we're going to learn about rational exponents. So we kind of already did rational exponents, but we're going to increase our knowledge with that. We have two rules that we're going to talk about. First of all, no improper fractions. So you remember we did that last time, where if we had x to the 7/4, you had to break that up and realize that that was 1 3/4. So you wrote that as x times x to the 3/4 power. Okay, that's not changing. So you want to make sure that if you have any answers that end up with that improper fraction exponent, that you break it down. Now I'm giving you a new rule. So you can't have any fraction exponents in the denominator. That's no fractions at all. Because if you remember, I showed you that the cube root of x squared is the same thing as x to the 2/3 power. So this fraction exponent is really the same thing as a radical. So if you have a fraction exponent in the denominator, you really have a radical in the denominator, and we know and we're very familiar that radicals in the denominator are a big fat no. So let's say we have something like this. Let's just start with an example with that radical in the denominator. 1 over y to the 2/3 exponent. So 2/3, that's a problem because we have a fraction exponent. So you have to multiply by something that's going to make it a whole number exponent. And remember, whatever you multiply on the bottom, you have to multiply on the top. So I went ahead and set that up. So I'm sticking with this y here because that's my base. Now, when we multiply the same base, we add our exponents. So if I have 2/3, how many more thirds do I need to get to that whole number? My answer is 1/3. So I'm having that exponent is 1/3. So now on the top, I have y to the 1/3, there's my fraction, and on the bottom, I just have y to the first power. Okay, that's really 3/3 because we added these exponents. That's where the 3/3 came from. Okay, so our final answer, you're not going to write your exponent as 3/3, you're going to write that as just 1. So y to the 1/3 power all over y. Okay, let's try one more of those. So you can see that I have this x to the 5/3 in the denominator. Now, it is an improper fraction, but the bigger issue here is the fact that it's just a regular fraction that's in the denominator. So what we want to do is we want to go ahead and multiply by something. The same thing on top and bottom. So because this is an x base, I'm going to use an x. So an x on the top and the bottom. Now my exponent is 5/3. So I have to think how many more thirds do I need to get to a whole number. So 5/3, if I do one more third, that's going to get me 6/3, or 2. So then I can do that 1/3 on the top. So now on the top, I can't really do anything with this x and this y, but I can go ahead and write it as x to the 1/3 y squared. I like my letters in ABC order. And then in the denominator, I have x to the 6/3. And you can see that's a 3. That this 6/3 right here, that's going to become 2. So my final answer is x to the 1/3 y squared all over x squared. So now in my final answer here, I have a fraction exponent, but it's not an improper fraction, so it's allowed to stay there. And then my denominator has no fractions. Okay, so before we go ahead and find some real examples, let me just tell you this right here. In order to simplify a term, you need the same base or exponent. Okay, they don't have to be both, so same base. That's going to be like your x, your y, your 2, your 3. Okay, the big number. So base, this is the base, and then the exponent is this piece. Okay, so base or exponent, not both. All right, let's get ready to get started. All right, so example 1, simplify each expression. So we want to make sure when simplifying our expressions, our final answer is only going to have whole number exponents or fraction exponents that are less than 1, proper fractions, no fraction exponents in the denominator, no negative exponents, and we want to make sure we simplify everything as much as possible. So here I have 2 of the same base, so that's what's allowing me to simplify this. Remember, you need the same base or the same exponent. So same base here, when I multiply things with the same base, I just add up my exponents. So this is going to become 7 to the 3/4. Okay, we're not evaluating. We're not typing that into our calculator. We're not getting any sort of decimal answer. That's our answer. 7 to the 3/4. It's a positive exponent. Yes, it's a fraction, but it's a proper fraction, so it's okay. All right, so example B popped up here. Now when you look at this, remember, you need either the same base or the same exponent to simplify. So within my parentheses, I don't have the same base. It's a 6 and a 2. They're totally different. I also don't have the same exponent, so I can't do anything, can't really do much at all. What I can do is I have this 2 exponent out here, so I can go ahead and distribute that. So when I distribute that, I multiply my exponents. So 1/2 times 2 becomes 1. So this is going to be 6 to the first power. And then I have times 2 to the 2/3 power. Now remember, this is really 6 to the first power. We're not going to write that 1, but as we evaluate our answer here, we don't have the same base and we don't have the same exponents. We cannot do anything further. So it's kind of weird, but that right there is my final answer. You can kind of think like if this was an x and a y, x times y to the 2/3 wouldn't be weird at all. The only thing that's making it uncomfortable for us is the fact that we have these numbers, the 6 and the 2. You can't multiply them. If you don't have the same base or the same exponent, you cannot do anything further. All right, checking out example C, we have the same base. We have a 5, and then it's over 5 to the negative 1/3. So this is telling us we can simplify it. The first thing you're going to want to do is you're going to want to notice that this exponent is negative. So whenever you have a negative exponent, that means you're going to take whatever has the negative exponent and you're going to pop it to the other side of the fraction. So because this is on the bottom, it's going to go ahead and move up. So that's going to give me 5 times 5 to the regular 1/3. Now, because there's the same base, you could think about taking this 1 power and then adding up your exponents. Well, if I do that, I'm going to end up with 5 to the 4/3. And then what do you notice just happened? Well, now we have an improper fraction, and we'd have to break that up to be 1 and 1/3 again. So this answer right here, where we just had that 5 times 5 to the 1/3 power, is actually the best and final answer because it's already broken up for us. If you went ahead and added them, you're then going to have to cycle back and separate them. All right, so if we look at example D here, we are checking first. We have the same base or the same exponent. Having one of those two is going to allow you to simplify a little bit. So no, I don't have the same base, but do notice that I have the same exponent here. They're both 1/3 exponents. So what that's going to allow me to do is kind of break this into 42 over 6 to the 1/3 power, and then all of that is still squared. So I kind of undistributed this 1/3. See what I did? If I were to redistribute that 1/3, I'd end up right back where I was. So what this is going to allow me to do is now simplify that 42 over 6, which is just going to be a regular plain old 7, and I still have that to the 1/3, and it's still to the second power, but then I can multiply my exponents because I have one base and a power to a power. So I'm going to end up with 7 to the 2/3 power. Now the 2/3 power is totally fine. It's not an improper fraction. It's not negative. Nothing crazy going on there. I'm not evaluating anything. I can't change that into a radical. I can't evaluate that. I can't change that into anything other than a decimal. So that's going to be my final answer. All right, so checking out example E, we've got 27p to the 3rd q all to the 1/3 power. So we don't have any same bases or same exponents within the parentheses, but we do have this 1/3 out here, so we can go ahead and distribute that. Now, this is not 27 times 1/3. This is going to be 27 to the 1/3 power. And then I'm going to multiply my exponents here. 3 times 1/3 is going to give me p to the 1st. We can write 3 over 3 for a second just so you see what's happening. And then I'm going to have q to the 1/3 power. So what I do need to take notice of is this 27 to the 1/3. Okay, unlike the 7 to the 2/3, I said you can't do anything. You could type that into your calculator to check. You're going to see you're going to get a big old decimal. If you wanted to think about the cube root of 7 squared, can you take the cube root of 7? No. That's why we didn't simplify it. But this 27 to the 1/3 power, if you think for a second, that's the cube root of 27. Well, what's the cube root of 27? If you break that down, 3 times 9, 9 becomes 3 times 3. There's those 3 3's that I need. So that's going to give me just a regular 3. So the 27 to the 1/3 power simplifies to 3. P to the 3 over 3 becomes regular P, and then I have Q to the 1/3. I can't do anything with that 1/3. It's a proper fraction. It's in the numerator, all as well. No negative exponents, no repeats. Looking good. Final answer. All right, we're just about halfway done. We've got 4 more examples. You can catch those in the next video. Don't skip that next video. Those are some super good examples. Keep it up, guys. You're doing great.